Alright, now let's get into our question. Our question states that we have a snapshot graph of a wave traveling to the right along a string at 45 meters per second. And at this instance, they want us to find the velocity at points 1, 2, and 3 of the string. So it wants us to find the velocity at point 1, the velocity at point 2, and the velocity at point 3. So since 1 and 3, we both know that they're at the mean, which just means that they are in the middle between the amplitudes, which is 2 and -2. We can use the Vmax equation right here that I got from the internet. And as for the increasing and decreasing, I will show you why we use each one in the next step. But for now, let's go to the variables that we have. So the variables we have is the velocity of the string, which is 45 meters per second, the amplitude, which is 2 centimeters, which I translated to meters, which is 0.02 meters, and then we have lambda, which is the wavelength, which equals 30 centimeters, which I then translated to meters, which is 0.30 meters. But the problem is, to be able to solve this equation, we need the angular frequency. So for angular frequency, we just need to find the equation for it. So we do know that velocity equals the angular frequency over the k constant, which is the spring constant, and that we can manipulate this to get the angular frequency is the k constant times the velocity. But since we don't have the k constant, we could plug it, we're going to need to find it. And we do know that the k constant is equal to 2 pi over lambda, and lambda is what we have right here. So we can plug that into the equation, which is 2 pi divided by 0.30, and we get 20.54 Newton meters. And then now that we have this k constant, we can plug it into this equation with the velocity we have up here, which is 45. And now we have 20.54 times 45, and we get 942.5 radians per second. So now that we have everything we need to be able to solve it, we can now solve for each point right here. So for V1, and the reason why we choose the negative equation is because the velocity is decreasing. Because as you see, as it gets to this top, the velocity is going to start slowing down, and as it's slowing down, that just means the velocity is going to be decreasing. So that's why we chose the negative. And when we plug in the amplitude, which is 0.02 meters, and the angular frequency, which is 942.5, we get negative 18.85 meters per second. As for point 3, it's increasing because you can see it's gonna, once it hits over here, the velocity is gonna start increasing on this side. So that's why we choose the positive equation. So we don't have to put the negative in the equation. And that's when we have 0.02 meters as well, times 942.5 for the angular frequency. And that gets us 18.85 meters per second. And for V2, the reason why I put this last is because this is really easy to calculate, because since it's at this top part right here, or max displacement, we know that the velocity is 0. So as a final note, one thing to just keep in mind is that at each point right here, at these endpoints, the velocity is just going to be flat, or the slope, you could think of it as a slope, it's just going to be flat right here. So that just means that the velocity, or technically the slope, since this is a position graph, that it's going to be 0. Yeah, and that's all.